a method has been put in a situation that it's logically impossible to correctly handle. So it's flat out impossible to do anything at all that could make the post conditions to be true. A method is supposed to read a file. What is the method supposed to do if the file doesn't exist? So integer parse int. What if you give it the string hello world? So the mechanism to indicate an inevitable failure at the semantic level of the program is that the methods, they don't return anything at all. So the old-timey way from languages that predate this kind of exception approach is that we reserve some return values. So especially if some return value is impossible, like you have a function that always returns an integer that is always known to be non-negative, so then you can return -1, so impossible result to indicate that there is no result. Then you can even distinguish -1 for one kind of impossibility and -2 for another kind. So then, but what if every possible return value is already in use, like for example here, so every possible int value is a possible legitimate result. So then we cannot use a return value, we cannot take from the domain of the return values any unused ones. So another possible approach is that there has to be some variable that both the caller and then the function can see. So if it's a boolean, so old-timey name for boolean flag, like a signal flag, so something that's either up or down, so in a two possible state indicating some kind of information. Or then it could of course also be an integer for an error code, so 0 would mean maybe success, and then anything non-zero means some kind of error. So this is the old-timey way to indicate, so they're failing silently and just returning something random, so that's just out of the question to begin with. But this why the exceptions are is that they have some advantages over this simple but old-timey approach. So then in the old-timey approach, the caller always has to immediately check if something went wrong, and then either forget to do that, or then if you cannot meaningfully fix the problem, then you just have to pass the bug to the next guy up the line, so you're gonna return some kind of other indication of error. And if suppose you have a deep chain of method calls in different levels of abstraction, so from the top level to some low level library. So if things go wrong at the top level, but this is revealed by something becoming impossible at the low level, so translating this information up the line, that everybody's reporting to their callers that they cannot do it, something went wrong. So then this propagation of errors and propagation of responsibility is not quite as easy. So the modern mechanism is that there is no result, not even null, so no result at all of any kind. Instead, using a completely separate mechanism, so then there's gonna be a different keyword to make it clear that these exceptions, they're not any kind of special return values, because literally nothing is returned from a method that is failing, because we're giving up, there cannot exist a legitimate result, so it's pointless to return anything at all because it would be wrong. So instead, the method execution is terminated in a different way. So the method throws use of the different word throw versus return to indicate which mechanism is being used. Throw a suitable type of exception objects. So these exceptions are yet another class hierarchy of their own. So the superclass exception, and then actually its superclass, even more general concept, throwable. So the type of the exception object that you return contains useful information. So this way, because the same method could throw different kinds of exceptions to indicate that things went wrong in different ways. So in the parse int, if you give it the hello world, so the only thing that can go wrong is that the string is not the legitimate encoding of an integer. So number format exception from the Java standard library is thrown to indicate that. Other methods, so when you look through their documentation, Then the types of the exceptions document what is the thing that can go wrong. So these always correspond to precondition violations. If a method has no preconditions, it has no excuse to fail. A method without preconditions can never throw any of these checked exceptions. These always correspond to precondition violations by the caller. Therefore, the caller, being at fault, must take care of the situation or pass the buck to the higher up the line. In the exception mechanism, so in the intentional use of two verbs, return versus throw. So now, if you know how to terminate the method and return a result, all you need to do is throw. So now, looking at this exception demo, don't look for any kind of a useful functionality. Again, this just demonstrates the language mechanisms. So we write a function here, let's call it fail1. And when a method can potentially fail, that you can inform the compiler and then indirectly the caller that when you call this method, there's a chance that you get an exception thrown at your face. And so this has to be declared with the keyword throws. So notice the plural s in here. Throws and throw are two different words. So now, here just the unconditioned, this is designed to always fail because this is just a demonstration. So throw, and you can return any objects whatsoever, but this mechanism allows you you cannot throw a string or an integer or a bank account. You can only throw things that are throwable, and the exceptions are throwables, and then there's another one that we'll see later. And typically there's no reason to create these exception objects beforehand. We just always create an exception object on the spot. Exception objects take a constructor parameter string, make some kind of a human readable error message, help in debugging. So when this exception information is propagated up the line and nobody can handles it, so then the program crashes and spits out the stack trace to the standard error. This shows in blue shape. This is the red stuff that appears at the bottom of the console window. So some kind of a meaningful error message, like if it's like an illegal value, so then make sure to include the value in the error message. Makes it much easier to debug what is going on. So throw, just like return, terminates the execution of the method. So like said here, execution does not get here. But now our sharp-type viewers wondering about this kind of thing. So if true, so why do we have this here? Let's comment out these two lines and see what happens. Don't compile anymore. So now the Java has the rule, like most languages, like Python doesn't have this rule. So because of the more dynamic nature of the Python, but this compile time checks they for every method look through the possible execution paths, and this statement is now unreachable. So we realize that there is no possible execution path from the start of the method that would lead to this statement, and in Java this is an error. So then so if your code contains unreachable statements, then your thinking must be wrong to begin with. So your thinking that produces an unreachable statement that can never affect the execution has to be wrong. So then it's reported as unreachable. So because every execution path has to get through the throw, and then there is no getting through it. So that's unreachable. But fortunately, so just like the semantic properties of the program, they're known to be algorithmically unsolvable. This was found out in the 1930s by Alan Turing and other people, even before actual computing machines existed. So that's how old this stuff is. That the question, is it possible for an execution to reach a given statement, yes or no? So then this question is actually algorithmically uncheckable. So how can we expect the compiler to determine which lines are potentially reachable? So the reachability criterion in Java is that essentially that every condition could always go either way. So we know that the true can only go one way, but for the purposes of the reachability analysis, so this is just like some kind of unknown condition that could go either way. So now viewed this way, just not looking at the content of the conditions, so now this line suddenly became reachable. This is now an error of its own, but let's replace it. So as it's not very difficult to fool the compiler to see this line as reachable. But anytime you call this method, it just throws an exception to your face. Let's try the blue J interaction. Well, I made it private, but let's make it public for a second. We'll see what happens. Yeah, so the exception, because nobody caught it, at the top level, the uncaught exception is printed at the standard error. So this is the standard output, what appear normally here. Standard error shows in red to distinguish from legitimate outputs. Theoretically, you could have a program whose legitimate output is this string, so that you can tell apart then the color coded here in the console.